take a look at how you can apply inequalities to solving with word problems. So let's take a look at this problem. You decide you want to work two different jobs this summer. Now, you could babysit the neighborhood kids for $10 an hour, which there are no taxes taken out of that money. Or you could work over at Culver's for about $8 an hour after all your taxes are taken out. You want to do both, and especially some hours at Culver's because you want some experience at a job situation. Your parents, however, have said you're kind of young, so they limit your work to 24 hours per week. What's the greatest number of hours you would need to work at Culver's and still make at least $200? So let's take a look at how I would kind of work my way through this. The first thing I'm going to notice is that there are a lot of things going on, so I'm going to do some highlighting. It says I'm working two jobs, and the final question wants to know number of hours for Culver's. So I'm going to highlight that green. Now I know that I've also got the neighborhood kids. That's one way I could make some money. And I know my Culver's, which is another way. So I'm just going to do some highlighting. I also know that I have a limit of 24 hours per week. And finally, I am trying to make at least $200. So this is a lot of different things that I have going on. Now, when I look at the problem, to me, I feel like there are two restrictions, two things that I'd have to meet, what I want and what my parents want. So, you want to make at least $200. Your parents want you to work no more than 24 hours. So what you have now is we have to kind of fit both of these requirements. Well, anytime you have a situation where you have to fit both requirements, that creates a system. We're going to write an equation for each of these requirements and then use those equations to become inequalities and then to graph. So the first thing I need to do is figure out what are my variables. According to my final question, it looks like a number of hours, but there are two different kinds of hours I could work. So let's let n be the number of hours. Actually, let's make that b for babysitting. Do b is the number of hours babysitting, and we'll let c be the number of hours at Culver's. So when I come over here, this first problem, you want to make at least $200. Well, if I think about that, I get $10 per hour to babysit, to which I want to add $8 per hour at Culver's. And if I want to be at least $200, then I'm looking at greater than or equal to 200. Now, when I come down here, your parents want you to work no more than 24 hours. Well, they're telling you that the hours you spend babysitting plus the hours you spend at Culver's has to be less than or equal to 24. We'll assume that you could squeak exactly 24 because it does say no more than. So here we have two inequalities. Well, if we're going to find the answer to this question, we're going to have to graph both of these inequalities on the same set of axes. Now, for me, I always prefer to use a hand graph, but for the purpose of this screencast, I will go and use Desmos. So first things first, let's get these things ready for graphing. So I'm going to change them to equals. And let's just say b is our x, so we'll solve. And let's see, negative 10 divided by 8 is going to be, let's use an equation, negative 5/4 b, and 200 divided by 8 is 25. So that's that one. Now let's go do my parents. This one's a little easier. I just move over the B and I'm good to go. So I need to take these two problems and I need to bring them over to Desmos and see what's going to work here. So I'm going to go over to Desmos. C equals negative 5/4 B plus 25. All right, let's get this so we can see it better. And C equals negative B plus 24. So here are my two lines. Now, I'm going to go back over to the problem. If I were to put in 0, 0, if I worked 0 hours, would that make my money problem true? I don't think so. That would not work at all. So here in Desmos, I need to get this thing to shade the red line away from 0, 0. So I'm going to change my symbol. Let's try greater than or equal to. Looks like we'll also have to make these back to X and Y. Wow, that's a lot of red. So all of this, ignoring negatives of course, would be ways that I could make more than $200. Now let's go back. 0, 0 would definitely meet my parents' criteria of less than 24 hours. So we need to shade that graph below the blue line. I'm going to just try less than or equal to because that makes sense. Wow, there it is. Let's make this bigger so I can see it. So now the question is, where, oh where, will I find the final answers? Well, let's bring this graph over so that we can look at it a little more closely. We'll do a little screenshot here. You'll notice we're only grabbing quadrant 1 because, well, quadrant 1 is all the positives. So let's go over here. I'm going to grab that graph. All right. So now, let's see what's going on with this graph and what does it tell us. Make this a little smaller so we can see it on a screen. So now, as I'm looking at this graph, where am I going to find the answers to both conditions? Well, probably pretty easy to see. That means I need the red and the blue to work, and red and blue make purple. So the purple region has the answers. That's anything in the purple region. So let's do a few samples. So let's see. Remember, we treated B as our X. So babysitting hours is down here, and Culver's hours is over here. So a few possible answers. I could babysit for 20 hours, Culver's for 3 hours. That would work. Or maybe I come over here and I say I could babysit for 10 hours, and that would mean I'd have to work at Culver's. Let's see, 10. Anything in here would work, so like 13 or 14 hours. But the question says, if I go back, what is the greatest number of hours you would need to work at Culver's? So we need to look at this graph and see if we can find where is the biggest part of this blue line that still falls within the purple zone. That's going to be up here, right where the two lines cross each other. So let's go back to Desmos. There it is. That crossing point is 4, 20. That would mean 4 hours of babysitting and 20 hours of Culver's. So to find the greatest hours for Culver's, We just have to find the highest purple point. And that is going to be where the two lines cross. So, the greatest number of hours you could work at Culver's is 20 hours. And that answers our question. Now, of course, any of those purple combinations would work. So maybe I'm not trying to max out my hours at Culver's. Maybe I just don't care. So anything in this purple zone would work for me. But if it came down to your parents wanting to know, well, what's the biggest number of hours we'd have to drive you to Culver's every day, every week, you'd say, well, I could work at most 20 hours in a week. That is how we can solve a word problem with inequalities. It just comes down to identifying your key information, identifying what you need to know, writing inequalities to fit the problems or conditions of the scenario, and then deciding, do you need to graph and how to find your final solution. Good luck with some of your problems, and hopefully they all go well.